In this video, we are going to talk about absolute error, relative error, and percent error. So let's do two examples sort of at the same time. Let's say that you are going to go to a donut shop. And in example one, you have you and your partner. And then maybe you have two kids. And let's say one of the kids had a sleepover, so he has two friends. So we have 6 people in total. So you're going to go to a donut shop and you're going to get a dozen donuts for breakfast. So that is 12 donuts. When you get to the donut shop, you ask for a dozen donuts and they hand you the box. And when you get home, you realize they didn't actually give you a dozen donuts. They only gave you 11 donuts. So we'll just put that here. So what we want to do is figure out the absolute error, how far off we were from what we expected. And the formula for absolute error is the observed value. So you open your box, how many donuts do you see? Minus the true value. So we know that a dozen donuts means 12 donuts, so the true value would be 12. And then we put it in absolute value terms. That's what these vertical bars mean. So that's just to say that regardless of if the number is negative or positive, we take the absolute value, so the number is going to be positive. Our observed value is 11. We opened the box and found 11 donuts. The true value, we were expecting to see 12 donuts. 11 minus 12 is negative 1. So our absolute error is 1. Now let's say we have a second situation. You are going to be in charge of bringing donuts for an event. So let's just say that you have a group that you're part of and you're doing some sort of award ceremony. And there's all kinds of your group mates there, but then also they're bringing their families and friends. All kinds of people are going to be there. So everyone that's part of the group is in charge of bringing something to the breakfast. Your task is to bring, this time, not just a dozen donuts, but a dozen donuts. So that would be 12 times 12, or 144. So you go to the donut shop and you ask for a dozen donuts, 144. That would be your true value. That's what you're expecting. When you open up the boxes to put the donuts on the table, you notice that one of the boxes is missing a donut. So instead of 144 as your observed value, we only have 143. And if you do that subtraction, that's negative 1, and the absolute value of negative 1 is 1. So in both of these scenarios, we have the same absolute error. Both orders, we were 1 donut short. In this first scenario here, since you only ordered a dozen donuts and you ended up just getting 11, that means one person is only going to get 1 donut. So in this situation, it might be a little bit more annoying that you only got 11 donuts when you expected 12. In this situation here, you're buying a whole bunch of donuts for a whole bunch of people, and other people were bringing other things for the breakfast. So being 1 donut short in this situation really isn't going to make as much of a difference. But the absolute errors are the same. So what we want to do is use a different type of error that sort of corrects for that. So it's important to know how far you're off. So we're off by 1 in both situations. But it's also important to know how far you're off in terms of percentages. So our next one is relative error. Relative error is the absolute error. Oops, forgot the T. So that's this right here, observed value minus true value, But now what we're going to do is we're going to divide it by the true value. So in this situation, our absolute error was 1. That's what we calculated up here. We expected to see 12 donuts, so 1/12. Or in decimal form, this is 0.083 repeating. In this situation here, we were off by 1, that was our absolute error, but we expected to see 144 donuts in all of the boxes. And when you write this as a decimal, it's 0.00694 repeating. So what you can see here is this number here is far greater than this number here, meaning that the error was much more. The absolute error was the same, but our relative error, this is a higher error. And then generally we're not going to express it like this. We're generally going to express it as a percentage. So percent error is the relative error times 100%. So it's going to be 0.083 times 100%. That means move the decimal to the right, 8.3%. 0.00694 times 100%, 0.694%. So you can see same absolute error, but this situation where we were 1 donut short off of 1 dozen donuts is a much higher error than being 1 donut short off of 12 dozen donuts.